Welcome back to The Explainer. I am absolutely thrilled to jump into today's topic. Look, if you've ever felt completely overwhelmed by all the dense jargon floating around in agile software development, you are in the exact right place. Today, we're stripping away all that intimidating tech speak. We're going to look at a wildly effective methodology called extreme programming, but we're definitely not doing it textbook style. Nope, we are treating this whole thing exactly like a driver's ed tutorial. Okay, buckle up, let's dive in. So imagine this. The founder of Extreme Programming, Kent Beck, tells this amazing personal story about his mom teaching him to drive on Interstate 5 out in California. Now, if you know I-5, it's just this incredibly long, flat, straight stretch of highway. His mom tells him to just point the car straight at the horizon. So he does exactly that. He squints down the road, locks his hands on the wheel, holds it perfectly still, and his mind wanders for just a fraction of a second. Bam! The car violently jerks as it hits the gravel on the shoulder. His mom calmly reaches over, steers them back onto the asphalt, and drops this piece of wisdom. Driving is not about getting the car going in the right direction. Driving is about constantly paying attention, making a little correction this way, a little correction that way. So, what does this actually mean for us? What exactly is extreme programming, or XP? Well, it's an agile software method that's completely centered around that exact same concept. Constant awareness, quick adaptation, and taking already good development practices and pushing them to the absolute extreme. Because think about it, just like driving isn't just locking the steering wheel in place and crossing your fingers, writing software isn't just creating a massive, rigid plan and hoping it magically works out 6 months down the line. It requires constant, tiny micro-corrections just to stay safely on the road. So here is our driver's ed syllabus for today's explainer. We've done the driving lesson, so next up is step 1, bring a navigator. Then step 2, check your mirrors. Step 3, make micro corrections. And finally, we'll wrap up with 3 practical tips you can use immediately. All right, let's get into it. Step 1, bring a navigator. Think back to a time you tried navigating a tricky, confusing new city completely by yourself. It is so stressful, right? You're sweating bullets trying to read tiny street signs while actively trying not to rear-end the car in front of you. Well, the absolute best part about this particular driving school is that you never have to drive alone. In XP, this is called pair programming. The roles are super clear. One person is the driver. They're the ones physically writing the code, hands on the keyboard, tackling the immediate problem right in front of them. The other person, they're the navigator. The navigator is reviewing that code in real time as it's being typed out. They're suggesting improvements, spotting typos, and keeping an eye on the bigger picture. This constant, ongoing conversation moves the solution forward so much faster. Plus, knowledge gets shared instantly between teammates, which completely eliminates those awful bottlenecks where only one isolated person knows how a specific piece of the code base actually works. Moving right along to step 2, check your mirrors. Okay, we've got our trusty navigator buckled in next to us. Now it's time to check our mirrors. In the software world, we call this test-driven development, or TDD. It's basically the equivalent of setting a highly precise GPS destination and checking all your surroundings before your foot ever touches the gas pedal. But before we get into the how, we have to talk about a major hazard on the road: scope creep. Let me give you an example. I remember once driving to the local grocery store for milk, but halfway there, I randomly decided, hey, I'm going to visit a friend 2 towns over. No extra money, no extra gas. That right there is scope creep. It's the uncontrolled expansion of a project's requirements without adjusting your timeline or your budget to match. It is a massive metaphorical ditch that you will inevitably drive your project straight into if you start coding without incredibly clear, specific boundaries. So how do we stay out of that ditch? Test-driven development. It's a strict, step-by-step cycle. Step 1, you actually write the unit test before you write any production code whatsoever. Step 2, you run that test. And yeah, obviously it fails because the code to make it pass literally doesn't exist yet. Step 3, you write just enough code, and I mean only enough, to make that specific test pass. And step 4, you refactor, clean it up, and repeat the whole cycle. By writing the test first, it acts as an unbending set of instructions. It tells you exactly what is needed. And maybe even more importantly, it absolutely prevents what developers call gold plating. You know, wasting precious time adding a bunch of unnecessary bells and whistles that nobody actually asked for. All right, on to step 3, make micro corrections. Okay, so we've got our navigator, our mirrors are checked, our destination is locked in. This brings us right back to Kent Beck's Mother on the Highway.
I actually remember when I was first learning to drive, I had this terrible habit of overcorrecting. I'd drift a bit, panic, yank the wheel, and nearly swerve into the next lane before jerking it back again. What we actually need are small, constant, gentle steering adjustments to keep the project safely in its lane. In XP, we call this continuous integration, and the absolute golden rule here is the 10-minute build. The goal is simple but powerful. Build the code, deploy it to a test environment, and run every single automated test, all in under 10 minutes. Continuous integration means your developers are pulling and integrating their code into the main system multiple times a day. If something breaks, boom, you know about it immediately. You are making a tiny steering correction the exact second your tire touches the lane line, rather than waiting until the car is already halfway off a cliff to realize, oh no, we have a catastrophic problem. Now, you might be asking yourself, why on earth do we go to all this extreme effort? Well, there's this deeply ingrained traditional assumption in software development that the cost of changing something grows exponentially over time. Basically, fixing a tiny bug late in the production cycle might cost you 100 times more money and time than catching it early during the design phase. But extreme programming challenges that entirely. XP operates on the really bold assumption that by using these strict, highly disciplined practices, we can actually keep the cost of change linear, predictable, manageable for the entire lifespan of the project. If you look at a traditional development cycle, that cost of change curve shoots steeply, exponentially upward as the months go on. It's terrifying. But with XP, that curve stays incredibly flat. Now, yes, adopting these extreme practices, like TDD and pair programming, it absolutely makes your present-day workflow a little bit stricter. And frankly, it takes some getting used to. It's a culture shift. But by putting in that rigorous discipline right now, we flatten the curve. We keep the entire software system highly malleable, which means when you inevitably need to make changes in the future, it is significantly easier and vastly cheaper to pull off. All right, time for our final section, 3 tips for immediate practice. We are safely pulling the car back into the parking lot. You survived! Now it's time to take what we've learned and get you fully ready for the actual open road. Here are 3 super actionable takeaways you can apply to your very next project to start building that XP muscle memory. Number 1, try writing just one single unit test before you start coding tomorrow. Seriously, just one. Feel what it's like to strictly define your destination before you hit the gas. Number 2, try pairing up with a colleague for just 30 minutes. Let one of you drive the keyboard, let the other one navigate, and just see how much faster you solve a tricky problem together. And number 3, take a really close look at your team's current build process. Can you streamline it down to under 10 minutes? Start chasing that rapid, continuous feedback. Which leaves us with a final provocative thought to chew on today. Take a step back, look deeply at your current workflows, and honestly ask yourself this. Are you just pointing your project at the horizon, closing your eyes, and just hoping you eventually get there in one piece? Or are you truly ready to actively take the wheel, make those crucial micro-corrections, and embrace the extreme programming mindset? I highly encourage you to test drive these practices and just watch how much smoother your ride becomes. Thank you so much for hanging out with me on The Explainer today, and I will see you next time.